And if you lose, don't worry, you're not going to be tested on this. But this, for those of you wanting to understand what's going on when you change sample size, my hope is this gives a little visual illustration. So every study is always imperfect. Specifically, we assume that the scores of our treatment groups reflect scores that would occur if we tested everyone in the population. That's what we have to do because we can't test everyone in the real population. So in other words, we use the scores from our study to estimate the average of the real population. However, this is rarely the case. Typically the situation is more similar to this. We have our sample, a bell curve. This is all that we can know. We have to assume that the scores of the rest of the population are similar to this. We have to just guess at what a normal person, the average population, would score based on our sample. Now, oftentimes, our sample is slightly off. So let's imagine, here's the mean or the average of our sample. Let's imagine that we could know or could test the entire population. These are the scores that would occur if we tested everyone in the entire world, the real distribution. Unfortunately, unless we test everyone, we can actually never know this. So we never know what this true mean score is. Remember, in statistics, the mean or the average is incredibly important. It is the way that this mean is what we refer to as our expectation about how people in a group will score. I've mentioned it once before last semester, but it's worth saying right now, and you're going to hear me repeat it a couple times again. All of statistics that we're going to learn has to do with three things: O, E, and D. Observation, expectation, and deviation. In other words, this mean or average score of the entire population is how we would expect a random person to score if all we knew was that they were a human being. We would expect them to score somewhere around this mean. That's not always true. Sometimes people score really high or really low. In other words, sometimes our observation of how people score deviates from our expectation. We'll come back. We'll talk more about observations, expectations, deviations. But for right now, what I want you to know is, and think about, is that the mean is important. Another way of saying this, let's see, let me ask you a question. How do we know whether our sample mean accurately reflects the population mean? So whether this mean right here accurately reflects this mean? Well, it depends on how confident we are that our mean is the real mean. Another way of saying this is, what is the likelihood that our mean would be this different from the real mean? This is what's called the standard error of the mean. Again, you won't be tested on this, but I want you to take a shot at trying to hear this and absorb just a little bit of it. So let's take a look at, in fact, let me erase some of this stuff. So what I want us to do is actually take a look at what's called the standard error of the mean. This is another way of thinking about the likelihood that our mean represents the entire population. So you could think about, this is roughly our 95% confident, 99% confidence interval. We are 99% sure that the true mean lies within here when we have a very large sample. In other words, for a large sample, we're really confident that our mean right here is close to the true mean. Let's see what happens when we start to reduce our population. When we have a very small sample, so 11 people in our sample, all of a sudden all of a sudden our confidence drops tremendously. Now we're only 95% sure that the true mean is this far away. In other words, our mean becomes much less sure. So how does sample size reduce the effects of error? How does that large sample make our standard error so small? Well, let's take a look. In other words, when we have a very small sample, our mean could be off tremendously from that true mean and still be within our 95% confidence interval here. Okay, so sample size affects error. So here's one way to think about our sample or our distribution. When we have a large sample, lots of people, our standard error is very small. As we start to reduce our sample and we have fewer and fewer people in our study, here we have 86 instead of 172, what we find is that standard error gets bigger. In other words, we get less confident that our mean is the same as the population mean. When you reduce it even more, so for instance here, to a sample size of 43, our error gets bigger, down to 22, it gets even bigger, and then as we saw in the last video, or in the last slide, with a very small sample, our standard error becomes enormous. In other words, we have almost no confidence that this mean score of 17 is similar to the mean population. We're 95% sure that the mean population could be somewhere between 11 and 23. In other words, a huge range. Whereas if we have this very large sample, we're 95% sure that the true mean is between 16 and 18, a very small range. Okay, so you're assuming that all things considered, if you don't give your experimental group the manipulation, they would score the same as the control group. So let's imagine here, let's imagine a different kind of experiment, a control versus a study program. And in the control group, you're imagining that if the study program did nothing, these two scores would be identical to one another. They would score the same, the control and the study, because the study program doesn't do anything. However, if we have a meaningful, a good study program, we're assuming that by manipulating one variable here, by manipulating how much they study, you're influencing another variable. Here, this is like a score on a test. You're assuming that the score is dependent upon their study habits. This is our DV, and this is our IV. So here we see that the mean score for the study program is higher than the mean score for the control group. There's a difference between those two. Maybe we can conclude that our treatment worked. What do you think? Why is simply comparing the means insufficient? Well, this is where we're going to turn when we look at our t-test. So really quickly, let's look at this data one last way. So if this is our control group, and this is our treatment group, let's imagine that we have really small standard errors. In other words, we're really confident that that a score in here is what the treatment group would get, or what the control group would get across the population. And we're really confident that the treatment group would score up here. In other words, we feel really strongly, we can be really confident that our treatment has increased the scores. Even though some people down here score lower than people in this group, and some people in this group up here score higher than a lot of people in our study group, we're still confident, because we have a big sample, that this study condition makes people score better than the non-study condition. But the question is, how big does the size have to be? Because here, if the standard error gets bigger, all of a sudden, now we're not confident. Look at all this overlap here between these two sets of scores. Now we don't know. Is one group really bigger than the other? We can't confidently say. So how big does it have to be? Well, it has to be big enough that these standard errors right here stop crossing. So if we have a really small sample size, the difference has to be huge in order to get our standard errors away from each other. If, remember, our sample size is big and we have these tiny little standard errors, well then the two scores can actually be really close to one another before they start to overlap. Here it is once again, this time looking only at the standard errors. You see, with the big standard errors, you have to move this far apart in order to get them separated. But with the small standard errors, you can move them very close to one another before they end up overlapping. Okay, that's a first shot through the standard error of the mean. If you understood any of that, you are light years ahead of almost every other psychology undergraduate in the country. This is something that usually you don't learn until you're a graduate student. But I wanted to give this as a little bonus video to give some of you a chance to try to get a sense of what's going on when we look at these statistics.